Hello and welcome back. I'm John, old YouTuber and gamer. It's Sunday today and I just start uploading the first video when this program is reading loud. I can speak a little bit English and read, but I don't read perfect English, so actually that could be helpful. If somebody is reading this loud that can speak real English, because many of this word I better understand the words if somebody who really speak English read it loud, then I can better understand it. So maybe somebody can use this video, somebody like me that's not English and not reading perfect high level English. It's about 1 p.m. today and we have a nice weather in Denmark. So, but let's start with this. So I just start to do this. That's my second time I do this. Let's just start the small one. I have some big one, like 40 or 70 pages, but let's wait about that. But we need to read the Intel, about the Intel Corporation. But the text, when you start to reading, it's not start to read like normal, it start to read something like this. So, but I try to show where it's reading, not always, but sometimes I get confused myself because it's jumping around in the texts. But this is a Danish show. Read loud, activate. Then read the whole documents.
Intel 4004. Intel 4004 Intel C4004.jpg. White ceramic Intel C4004 microprocessor with gray traces. General information. Launched November 15, 1971. Discontinued 1981. Common manufacturer S. Intel. Performance max. CPU clock rate 740-750 Ps. Data width 4 bits. Address width 12 bits. Multiplexed. Architecture and classification. Application. BASIC calculator. Arithmetic manipulation technology. Node 10 instruction set 4-bit. Oriented physical specifications. Transistors 2,300. 1. Package S. 16-pin DIP. Socket S. DIP 16. History. Successor Intel 4040. The Intel 4004 is a 4-bit central processing unit, CPU, released by Intel Corporation in 1971. Sold for $62. It was the first commercially produced microprocessor, 3, and the first in a long line of Intel CPUs. The chip design, implemented with the MOS silicon data technology, started in April 1970, and was created by Federico Fagin, who led the project from beginning to completion in 1971. Marcian Horth formulated and led the architectural proposal in 1969, and Masatoshi Shima contributed to the architecture and later to the logic design. The first delivery of a fully operational 4004 occurred in March 1971 to Bisicom Corporation of Japan for its 141PF printing calculator engineering prototype, now displayed in the Computer History Museum in Mountain View, California. 4. This calculator, for which the 4004 was originally designed and built as a custom chip, 5. was first commercially available in July 1971. Federico Fagin accomplished what no one had achieved before, to fit a general-purpose CPU into a small, commercial silicon chip. He invented a technique to design and lay out 2,300 random logic transistors into a single chip with 5 times the speed and twice the circuit density, half the cost, of the incumbent metal gate technology. This unprecedented integration was achieved through a new process technology he invented at Fairchild Semiconductors in 1968. the Mohs Silicon Gate Technology, SGT, which he pioneered in the first commercial SGT IC, the Fairchild 3708. To design the Intel 4004, Fagin used the SGT with two new inventions of his, the buried contact and the bootstrap load-in silicon gate, which made possible the necessary speed, power and cost for a useful general-purpose microprocessor. The 4004 was the first random logic circuit integrated in one chip using the Mohs metal oxide semiconductor, silicon gate technology, SGT. It was the most advanced integrated circuit, IC, design undertaken up until then. Hof, head of Intel's Application Research Department, had formulated an architectural proposal consisting of a block architecture with an instruction set during 1969, while talking with BISICOM engineers led by Schimmer and with the assistance of Stan Maser. Hof and Maser were not Mohs chip designers and did not participate in the actual design or development of the 4004. The chip design was realized independently in the Mohs department, different from application research. It could only be realized by a designer with deep knowledge of Mohs process technology and of the new SGT. Fagin was hired at Intel in April 1970 from Fairchild Semiconductor to be the project leader and designer of the 4004, and he transferred to manufacturing a fully functional chip in March 1971. Fagin brought to Intel his mastery of the SGT Thav had invented at Fairchild in 1968, and used it to develop his novel methodology for random chip design. That was key to making the first and all the early Intel microprocessors. Schimmer, representing BISICOM, was engaged with Hof and Maser in the architectural phase during 1969, and he also assisted Fagin with final logic design for 6 months in 1970. In November 1971, with the prophetic advert announcing a new era in integrated electronics, the 4004 was made commercially available to the general market. The 4004 was the first monolithic processor, fully integrated in one small chip. 6. Such a feat of integration was made possible by the use of the new silicon gate technology for integrated circuits, originally developed by Fagin, with Tom Klein, at Fairchild Semiconductor in 1968, which allowed twice the number of random logic transistors and an increase in speed by a factor of 5 compared to the incumbent Mohs aluminum gate technology. 7. Fagin also invented the bootstrap load with silicon gate and the buried contact, improving speed and circuit density compared with aluminum gate. 8, 9, 10, 11, 12. The 4004 microprocessor, the 4001 ROM, 4002 RAM, and 4003 shift register constituted the 4 chips in the Intel MCS4 chipset. With these components, small computers with varying amounts of memory and E/O facilities could be built. Contents: contemporaneous CPU chips, history and production name and variants, technical specifications, logic levels, support chips, packaging, use, legacy and value. See also notes, references, sources, patents, historical documents, further reading, external links. Contemporaneous CPU chips. 3 other CPU chip designs were produced at about the same time. The 4-phase systems L1, done in 1969, the MP944, completed in 1970 and used in the F-14 Tomcat fighter jet, and the Texas Instruments TMS-0100 chip, announced on the 17th of September, 1971. The MP944 was a collection of 6 chips forming a single processor unit. The TMS-0100 chip was presented as a calculator on a chip with the original designation TMS-1802NC.13. This chip contains a very primitive CPU and can only be used to implement various simple 4-function calculators. It is the precursor of the TMS-1000, introduced in 1974, which is considered the first microcontroller, i.e., a computer on a chip containing not only the CPU, but also ROM, RAM, and I/O functions. 14. The MCS4 family of 4 chips developed by Intel, of which the 4004 is the CPU or microprocessor, was far more versatile and powerful than the single-chip TMS-1000, allowing the creation of a variety of small computers for various applications. Zilog, the first company entirely dedicated to microprocessors and microcontrollers, was started by Federico Fagin and Ralph Ungerman at the end of 1974. 15. 16. History and production. National Semiconductor was a second-source manufacturer of the 4004, under their part number INS 4004. 17. The first public mention of 4004 was an advertisement in the 15 November 1971 edition of Electronic News. 18. The first delivery was to Bizicom for their engineering prototype calculator in March 1971. 19. 12. Followed by their 141PF prototype calculator commercially available in the market in July 1971. 20. Packaged in a 16-pin ceramic dual inline package, the 4004 was the first commercially available computer processor designed and manufactured by chipmaker Intel, which had previously made semiconductor memory chips. The chief designers of the chip were Federico Fagin. The leader of the project after the architectural definition was finalized with Bizicom, who created the design methodology and the silicon-based chip design. Ted Horf, who formulated the architecture. 21. 22. Both of Intel, and Masatoshi Shima of Bizicom, who assisted in the development. Fagin, the sole chip designer among the engineers on the MCS4 project, was the only one with experience in metal oxide semiconductor, MOS, random logic and circuit design. He also had the crucial knowledge of the new silicon gate process technology with self-aligned gates, which he had created at Fairchild in 1968. At Fairchild in 1968, Fagin also designed and manufactured the world's first commercial IC using SGT, the Fairchild 3708, 23, that was featured on the cover of Electronics, the 29th of September, 1969. 24. As soon as he joined the Intel MOS department, he created a new random logic design methodology based on silicon gate. 20. And contributed many technology and circuit design inventions that enabled their single-chip microprocessor to become a reality. His methodology set their design style for all the early Intel microprocessors and later for the Zilog Z80. He also led the MCS4 project and was responsible for its successful outcome, 1970-1971. Marcian Ted Horf, head of the Application Research Department, contributed the architectural proposal for Bizicom working with Stanley Maser in 1969, then he moved on to other projects. When asked where he got the ideas for the architecture of the first microprocessor, Horf related that Plessey, a British tractor company, 25, had donated a mini-computer to Stanford, and he had played with it some while he was there. Shima designed the Bizicom calculator firmware and assisted Fagin during the first 6 months of the implementation. The manager of Intel's MOS design department was Leslie L. Verdes. 26. At the time of the MCS4 development, Verdus's attention was completely focused on the mainstream business of semiconductor memories, and he left the leadership and the management of the MCS4 project to Fagin. Bizicom had designed their own special-purpose LSI chipset for use in their Bizicom 141PF calculator with integrated printer. They based their design on the architecture of the Olivetti Programmer 101, one of world's first tabletop programmable calculators, which Olivetti introduced in 1965. 27, 28, 29. Bizicom commissioned Intel to develop their design for production. Like the Olivetti Programmer 101, the Bizicom design used serial read-write memory. The Bizicom memory was based on MOS shift registers rather than the costly Olivetti memory based on magnetostriction wire. Intel determined that the Bizicom design was too complex, since serial memories required more components and would use 40 pins, a packaging standard different from Intel's own 16-pin standard. Intel proposed to develop a new design that could be produced with standard 16-pin DIP packaging and would have a reduced instruction set. 30. The memory simplification would come from using Intel's newly developed dynamic RAM memory. This new design was the 4004 chip, which is one of a set of 4 chips along with ROM, DRAM, and serial to parallel shift register chips. The 4004 was subsequently designed by Federico Fagin, 31, using silicon gate technology and built of approximately 2,300 transistors. 1. It was followed the next year by the first ever 8-bit microprocessor, the 3500 transistor 8008, and the 4040, revised and improved 4004. It was not until the development of the 40-pin 8080 in 1974, a project conceived and directed by Fagin, 32, that the address and data buses would be separated, giving faster and simpler access to memory. The 4004 employs a 10 micrometers process silicon gate enhancement load PMOS technology on a 12mm 2-die. 33, and can execute approximately 92,000 instructions per second. A single instruction cycle is 10.8 microseconds. 34. The original clock rate design goal was 1 MHz, the same as the IBM 1620 Model I. The Intel 4004 was designed by physically cutting sheets of rubylith into thin strips to lay out the circuits to be printed, a process made obsolete by current computer graphic design capabilities. 35. For the purpose of testing the produced chips, Fagin developed a tester for silicon wafers of MCS4 family that was itself driven by 4004 chip. The tester also served as a proof for the management that Intel 4004 microprocessor could be used not only in calculator-like products, but also for control applications. 36. Name and variants. The Unicom 141P is an OEM version of the Bizicom 141PF. When Fagin designed the MCS4 family, he also christened the chips with distinct names: 4001, 4002, 4003, and 4004, breaking away from the numbering scheme used by Intel at that time, which would have required the names 1302, 1105, 1507, and 1202 respectively. Had he followed Intel's number sequence, the idea that the chips were part of a family of components intended to work seamlessly together would have been lost. 37. Intel's early numbering scheme for integrated circuits used a 4-digit number for each component. The first digit indicated the process technology used, the second digit indicated the generic function, and the last 2 digits of the number were used to indicate the sequential number in the development of the component. The 8008 microprocessor was originally called 1201, per Intel's naming conventions. Before its market introduction, the 1201 was renamed 8008. Following the new naming convention started with the 4001/4002/4003/4004. Tadashi Sasaki attributes the basic invention to break the calculator into